Hello. Hey, it's been quite some time now since the last live stream. How are you guys doing? Today we are doing Zig. Yeah, I had to change it. I forgot about like the last live streaming. I will do an announcement on the Discord server. Oh, and also maybe just share the Discord server here on the chat. Okay. No, I was on Twitch. Wait, let me like. Okay, probably my voice was too low. Hello. So I started doing live streams on Twitch, but then I realized that I had way more followers here on YouTube, and so I just moved completely here on YouTube. Hello, Hell. Okay, so those who are on the Discord server probably already know what we are going to do today, but I will explain for those who aren't, and really you should join the Discord server. Yeah, today an ECS, but before that, I want to disconnect the microphone from my headphones. Okay, it was driving me crazy. Sorry, I had to. I don't think he's. How do you say that? Yeah, he's definitely lucky. Okay, so to implement this, today we are going to use something that's called a Sparse set. Let me show you the data structure. Which is this thing here. Very, very simple data structure. And this is like common for an entity component system implementation, which is opposed to archetypes component system, which is what Unity uses. But it's very complicated to implement, so for now, I will just use the Sparse set. And the project I'm working on is a real-time strategy game, which is set in ancient times, so you can like play with the Romans, ancient Greeks, Egyptians, and so on. And it's going to be written in Zig. I took my voxel engine, the one I worked on in past lives, as base code, so that I already have Vulkan renderer, and now I'm going to work first more on the logic and then go back to rendering. Also because I want to procrastinate on rendering, because for that I will probably need some kind of assets and I don't really know how to get them. Why did you choose Zig, not C++? Well, not C++ because I hate C++, mostly. I mean, the language itself is too complex and it adds a lot of stuff that it's not really necessary to me. So I really prefer a more simple language like Zig, which is like near C in terms of simplicity and in terms of performance, but still adds some cool features of more modern languages. And also I really don't like object-oriented programming, and the creator of Zig made this language specifically to be used with data-oriented design. And also I wanted to use the language because I like it. Okay, so just one announcement and then we can start. The repository for this project is on this website, and I will share it here in the chat. But I also made a mirror on GitHub, so you can also find the same repository on my GitHub profile, but I will not accept issues or pull requests there. Okay. And that said, we can start now. Yeah, Hell knows something about this. We were playing a similar game together, which heavily relies on object-oriented programming, and it has terrible performance on the CPU side. So rendering is quite good. The frame rate is quite high, but still, you can see the game logic lagging a lot. Anyway, I already made the folder for it, and I intended to use archetypes, but we will not, and so I will just remove that completely. And instead we will be using a sparse set. So I will create the new structure, which is the sparse set. And the sparse set is just a struct containing two vectors. And Zig has vectors directly in the standard library. Oh, yes, of course. Okay. Is it better now? Okay, so yeah, I think I will be using array lists for this. Very, very simple. Okay, and I think that array lists I think that they are always packed. So if you remove something here, it will shift all of the rest back. And that's what we want in this specific case. But just to be sure, I will check that. So let's see. Oh. Okay. So I want to create an array list which is std array list. So I will just need an allocator for this. Okay. And so this is an array list of types U8. Okay. And what I want to do is try doing something like this. So I will say that buffer, and probably I can't index it. I don't want to append, but to can I like insert? Yeah, okay. I want to insert at index 4 the value a. Then I will remove the index 4, and I will set index 5 to be b, and then print, so std debug print I will print buffer dot, and is there like some kind of get? Yeah, okay, get 4. Let's see what happens. Oh. Okay. There is no remove. What? Oh. Yeah, so I can't really remove from an array list. I can do an order remove. Okay. Expected union type. What? Wait, let me check the documentation. Please be a little bit quicker. Okay. Std array list. Contiguous. Okay. So can I remove index e? Okay. This is also interesting because I will need this later on. Nice to know there is. And okay. Value of type. Okay. No field. So how can I like get an element at a specific index? Can I like get the row data? So there is, yeah, there is a slice. So I can just get items, I guess. Buffer dot items 4. Can I do something like this? Oh. Okay. Start index 4 is larger than end index 0. Okay. So I can't really insert something on index 4 because this thing is packed. So I can't use this for the sparse array, but I can use this for the dense array. Let's see if there is some kind of array list. Okay, what's unmanaged as a parameter? Okay. So in this case, okay, it's not really what I need. Well, I guess I will have to use a simple array. An array hash map? I don't need an hash map. Like really, I don't need an hash map, so that's why. Well, okay, I will use a regular array for this, but it's kind of weird for me that, like, if I have an init capacity, I have the space for this. So can't I do something like buffer.items 4 equals to a? Can I do something like this? It looks like I can. Length 0. Okay. Resize. So what if I buffer.resize 100? Try. Okay. And yeah, this should be a character. So let's see. B. And yes, okay. So when I set the 4 to be A, then I set the next one, so the number 5 to be B. Then I remove the 4, and the 4 had the same value I assigned to 5. So it shifts back. It shifts back whatever I had there. So I will need to... Okay, this is packed. And also I want to check, because I saw there is swap remove. Okay. The empty slot is filled from the end of the list. Okay, so this is what I need for the dense array. Basically, most of this data structure is already implemented in the standard library itself. So that's something very cool. So again, sparse set is a structure, and I will have a sparse, which is an array list with type. This will be just an index, so usize. And then I will have a dense array, which is another array list, again with an index. Okay. And I will have to implement some methods for this. And one is when I want to insert a new element. So void, function, it's public function insert, which will be a void. And here I will take self as sparse set, as well as well, the index for the entity. So, well, not really. This should just return the index, and I will show you why in a minute. Okay, and I also wanted to use zig testing because I never used that. So sparse set. So how does zig testing works? Okay. Zig test. So oh, okay. I will just import this inside of main. Okay. And then here I will try to call this sparse set. So I will create a new sparse, which is a sparse set init. Okay, and here I will have a new sparse set. With sparse being equal to std array list. And I don't remember how you initialize this. Okay, so init capacity, and yeah, capacity will just be like 10. I think it's correct number, and this should be an equal. And then, oh, of course, this should be. Is it correct? I don't remember how to like expected at line 9. What's the problem? Oh, array list should be usize like this, and then same thing here, usize, but still there is a problem. Column 20. Here it's expected. What? After initial. Oh, wait. Okay. I didn't remember how you use zig because I haven't been using this for quite some time. Okay. Then I want to check renderer. Okay. So this will get just an allocator as a parameter. Okay. And then here I will need to create an allocator. So I will just copy this. Okay. And then I also have to de-initialize all of this. And so self Okay. So the sparse the init, and here, okay, this is pretty straightforward actually, because I just have to push a value. Wait. So for now, I will focus only on inserting, and then we will see for removing stuff. So inserting is quite easy, because I can just like I can just take the index of the length, so I will have constant index, which is the self sparse length. Do I get length? So how do I get this? No, I want to have an index, but node. No, I need to know how many elements are in the list. Okay. How is it possible that I can't know? Well, I guess that I will just okay, my connection is very slow. Wow. Oh, just like this? Okay. But this is like, I thought this was something like the capacity. But okay, so items length. Okay. I will return the index, and I will just self dot index, so self dot sparse dot append, and here I need to append an index which will be the index inside the dense array, and in this case it will be self dot dense append. So here the dense array will now contain the index. Okay, and so dense index will be equal to self dense items length. Okay, length. Then I will insert this here and this here, like this. Okay, so this is quite easy, I would say. And what else do I need to do? Well, basically this is like all I need, because then when I insert entities, they will just grow. and they will be sparse inside the sparse array and strictly packed inside the dense array. And this way I can just iterate quite easily over the dense array, and I will be very cache friendly and so have better performances overall. This is what entity component systems aim to do, like use quite well the CPU cache. But now what about like removing? Because I could just very easily remove items, but I want to save space for entities. I don't want the thing to grow infinitely. Let's see if I have some kind of visualization. Okay, here it is. Okay, so here they push to the dense array. Okay, yeah, that's exactly what I did. So I will push here and then set the value to the entity number. Okay. But like I want to know which entity IDs are available. So how do I know precisely which entity numbers are available? Yeah, he just pushes. Okay. So the actual entity index should be allocated external, like from another place here. Okay. And I don't want it to like grow indefinitely, like forever. So I have to set this in a way that I can recycle IDs. Okay. I think I will use a linked list of values I can then pop and push. So when I remove an entity, I will put that entity ID inside the linked list of free entities and just use that. And if the like destroyed entity linked list is empty, I will push the entity in the sparse set. Okay. Does it have a linked list? No? Oh, but yeah, I can just use an array list because they still have O1 append and push. Defer. Oh, if I did so, That's an error. Oh, no, it's not, because, wait, let me see. Because I don't remember. I think I'm calling that here, yes. So here I destroy the renderer. And destroying this we'll call device destroy. Okay. And so device should be declared here. Destroy. I don't see the destruction of the device. Oh, hello. I don't see the destruction of the device anywhere. First line of destroy renderer. Oh, okay. So this is because I need to call... No, wait. How is this? This shouldn't work because the device should be destroyed after that. Oh, but because the fur... Okay, happens next. Yes, okay, this is redundant. This can be removed. Yep. It can indeed be removed. Okay, thank you for making me notice. No, I will not. I know you are going to submit a patch. Don't worry. Okay, I will just work on the entity component system now. Why it's not loading? Like, please. Array list. Okay, if I call pop, okay, I will also set here a destroyed. No, well, just free IDs, which is another array list. Okay. And here, when I take this index, I will first check if self free IDs is empty, then the index will be var index equals 0, index, okay. Well, actually I can just do the other way around. So, like, by default I will set it to this thing here, and if this is not empty, this will just be self free IDs.pop, like this. Should just work. Okay. And so now I can also remove an entity from the sparse set. And here I will just take the index for the entity and return nothing. Missing parameter name? Oh, yeah. Okay. ID. Okay. And this should be quite easy, because now I know the ID, so the index will just be self sparse data ID, and this will be the index of the self.dance.data index, and here I will have to swap remove this. So I can just call dance swap remove index. Okay. And then I have to, before doing this, I have to change, like to get what's the last one. Can I last get? Okay. So const last is equal to self.dance.last, and with this, I will have to update. I want to get the value of this. Okay. So I will have to update this thing, because now here I will get the entity ID for this one, and I have to update it to be the old index. Okay, so before removing, I will update sparse, so self sparse.data at index last will be equal to index. Okay, and then I just swap remove at index, so that in place of index there will be the last element, just like that. And this should really be it. I just have to also de-init this, and here I should then add ID. So free IDs dot push ID. Okay. And here I will try to sparse insert. Okay. And I will get const entity. Okay. And I want to print this thing. So debug.print ID. Okay. Then I want to, well, let's add 100. So for 0 to 100, I can just ignore this thing and insert 100 entities. Okay, and then I want to like remove entity number 6. So sparse remove ID 6, and then I want to see what will be the next ID I get. So new ID, and this will be sparse.insert. Okay, this should be struct. So what if I now do, let me increase this zig test. So like name sparse, oh no, zig build test. Okay. How does this thing work? I never used tests, but they are cool. Step test. Okay. Unit test. Root file. How zig test in projects. Okay. Oh. So I need to add this here. What? Wait. This is not true. Because it actually works. So this is something related to tests. Well, okay. I guess no unit testing for now. I will just... is it okay if I add some checks? Yes, of course. Add whatever check you want. And... okay, so no testing. I will just... pub function... I don't know. Well, test sparse. Because I don't want to lose too much time try to figure out how unit testing works in Zig. And then I will just call this function from the main one. Okay, so before doing anything, I will components test sparse. Yeah. So this is try, and try. And also where is it? Insert try and same thing here. Okay. Because sparse should also be a try. What else? Okay. Var. Ooh. Is it just len? Or what? There should be. Len. Okay. Oh. How do I know the length of an array? Okay. It's just len. Are you coding a game engine? Yes. I'm coding a game engine. So there is no way of knowing if this thing is empty. Well, okay. What does pop return? Okay, so I can just do the other way around. Free IDs dot pop, and if index is null, then this will be self.sparse.items.len. Okay. And here. Union is ignored. What do you mean? Oh. Well, yeah, I can assure that this is actually contains a value. So, do I really have to use an if statement? Well, I can just do or else 0, but I know that this will never be 0. What? Oh. Okay. This shouldn't return any error. And this is not push, but append. Okay. Because it's not data, but it's items. It's not last, but it's get last. And the swap remove returns. What does the swap return? Swap remove. Remove the element at the specified index and returns it. Okay. Well, I don't need this. Okay. Oh. It worked. It looks like it's working. I want to iterate over the dense array and see. Well, I should remove some random values here. like 6, 3, 7, 10, 54, 24, and 13. Yeah, I won't use higher numbers because I have 100 entities. And what else? Like, I don't know, 93. Okay. So technically this should be something like 24 exactly, because it was the last one. But now, what if I go for, if I remember correctly, I can just do sparse dense and then have the entity and just print the entity. Oh. Okay, I should definitely put a new line. Okay. So it's kinda ordered. But here, as you can see, there is 92 and then 98. Okay, so it's almost ordered, except, yeah, like when you swap stuff, it gets out of place, as you can see here. Okay. Well, it looks like the Sparse set is indeed working. That's very good. Nice. Okay. So what I want to do now, I should create other dense arrays containing components, like component pools, which should be aligned to the entities inside the dense array. So for each index in the dense array, I have an entity index, and for each index inside the dense array, there should be an equal index inside the component list assigned to an entity. And now I'm thinking, what if an entity doesn't have a specified component? What do I do in that case? What should I do? Yeah, I haven't really thought of this, because I can't align an array if those arrays have different sizes, because it would get a mess. So what can I do? I could technically wait, let's see if I can find something about this. Sparse set ECS. Let's see this. So here I will have, okay, component list. It is aligned. Entity list N, component list N. So this should probably be done for, I should have a sparse set for each different component type, I think. But then what about the views? First getting the smallest pool requested. Okay, this makes sense. And using these entities. Okay, so first I iterate over the first array and then get the entities by direct access. Okay. Okay. So I should create a sparse set for each different component type. So that, okay, yeah. It's not hard. So for each component type, I will create a sparse set, and then that sparse set will have a dense array and a component pool, which is another dense array. And then I can just insert entities and stuff there and iterate over the dense array of which has the smaller size. Okay, I will show you this. So I want to have a component pool which will be a structure, so constant pool, which will be a structure containing the sets, which will be a std hash map. What hash maps are there? Okay. Hash map. Okay. So auto hash map of the key will be a type, so a component basically, and this will be a pointer to a sparse set. Just like this. Well, technically I could just have directly a sparse set, not necessarily. Okay. And I want some functions. For example, pub function. Pub function. So I will have to like register component. Okay. And for each component, what's the problem here? Oh yeah, which is a void, and I need to get self. And of course a type. So component type. For each one I will have to sets insert for component, and here I will just create a new sparse set. So sparse set init allocator, sparse set init, and as such this will return a result, and here I also need to pass the allocator. Okay. Just like this. Do you want to enforce having validation layers? Yes, but only in debug mode, of course. So validation layers should be there only when debugging. Okay. Is this okay? Well, it will probably not compile it unless even if the user doesn't have them. Well, in that case, no, not really, but I should probably notify the user of not having them. Like, they are not obligatory, but they are suggested. So yeah, maybe just don't crash directly, but tell, hey, you are in debug mode, you should have validation layers. Yeah, like a log. Okay, let's create some. Like, I will create a speed component. And here I will just create a new pool. Which of course should be somehow initialized. So public function init, which will return a pool, and we'll probably need an allocator. Okay. Yes. So return pool Okay. Then I should also de-init. Void. Oh. Okay. And this should be a try. Unable to resolve comp time value. Okay, it makes sense. Yeah. So what do I do in this case? Because I still want somehow to like get components from an hash map. At least component sets from an hash map. I should probably assign them some kind of identifier. Well, I can like have constant ID equals to yeah, like this, I think. So and then here just use usize and usize. Okay, this is good. And so here I will then just pull register component speed.id. Can I? Expected type. Oh. Usize. So you don't insert stuff? What do you do? Put. Okay. 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 So now we have the component pool. And I have to... So I can't allocate this here. The entity ID should be allocated from the component pool. So these sparse sets should just directly get an index. So I don't care about this. And this should be ID, not index. Okay, where is the other index? Oh. Well, this shouldn't even return anything at this point. Just like this. Okay. And I will move the logic for removing and adding stuff here in the pool. Public function insert, which will return usize and get pool. Okay. Okay, and I want to keep track of how many entities are there. So well, entities. Okay. Okay. So here I will just have so add component should get. Oh wow. So now adding component these ways. It's not easy. Wait, let me first think of how I should go adding component. Component. Here I will just have t type, and this should be comp time. Okay. Okay, I know that there is a way in Z to check if a type has a specific member, so I can just check that T has the ID member, which should be an usize. In that case, it's a valid component, and I can add the component just like that. So what does it? Okay, field. Okay. And what if there is no field with that name? Oh, I guess it just crashes probably. So I can get an ID. Okay, can it really do something like this? Wow, that's crazy. Okay. Zig is very cool for this kind of stuff. You can really manipulate the source code. Okay, so now I know the ID. I know I have an entity, and I can just go on to self sets I don't think, no, okay, those are ape allocated, so it's not possible. You just get component ID. Try, okay. And then I will go on and insert the ID for the entity. Okay. And the sparse set here should have some kind of, whoa, wait. Okay, so I should modify the sparse set to also have an array list. So a dense array list of T, which should be a type known at compile time. Where is the device definition? Because I don't really remember how you do this kind of stuff. Oh, okay. Oh. Okay. So function sparse set. Okay. No. Oh, it returns set type. Okay. And this will be called not dense, but components. Okay. And so when I insert something, I'm not only inserting an entity, but I'm also inserting a component. Self components. Okay. And here I know for sure that the dense array and the component array will be equal. So I can really just I can do the same thing I did here. So here I will just self components swap remove index. Okay. What? Oh, yeah. Okay. And so here in the set, I will insert the specified ID. I will insert the component. Okay. And where am I initializing this parse set? Here. Okay. I will just say that this is a type. Time component. Okay. And this will be field component ID, because then I will have sparse set component like this. And if I got this built-in function correct, this should just work. And so here I will do something like this, and everything should work. Let's see if it compiles at least. Expected type. Okay. Expected 2 arguments, found 1. What? Oh, also the allocator. Okay. Pardon. What? Oh, it's not here. It's here. Yeah. And this should be try. Okay. Init should return. Can I do something like this? Okay. Okay. So this isn't okay? Are you telling me that? Okay. Yeah, because those are compile time functions. So I should know this at compile time. Okay. But I do indeed know at compile time. Yeah, I know which components I will have at compile time. So technically, yeah, sadly I can't really store them in an array and then iterate it at compile time. I can execute arbitrary code, but this is probably not something I can do, or at least I don't know how to do that. Yeah, because here I should have something like sparse speed. But this shouldn't be an hash map of sparse speeds. It should be something else. But I could have an array list of types. No. How am I going to do this? Oh, by the way, guys, remember to join the Discord server. I still haven't said that today. Okay, this is like not very easy to decide because this will indeed influence a lot how I will like define my whole engine. I mean, right now I could just create a sparse set for each type manually. What? Ah, well, you know, documentation is always appreciated. Especially since I would like a lot people contributing, so that's even more useful. Okay, so for now I will just speed set, do something like this, and then I will think of something different. So speed set will be a try sparse set speed. Okay, I don't need this function anymore. And adding a component to an entity. Oh well, but now I still have the other problem. Okay. It's harder than I thought. Definitely harder than I thought. because so here I have to dynamically access the components, because here I just know that I want to add a component, and I know its type. So from the type I can get the identifier, which is connected to that set of components. But then, like, the only thing I could technically do is a hash map, which maps every ID of every component to a string of the field, and then access the components from the hash map with the fields. That's the only thing that comes to my mind. Yeah. So basically something like this. Sets map. Which takes usizes and give me pointers. I mean strings. Okay. So here I just set map. Okay. And yeah, I want to fill this thing here, so var sets map. Okay, and then insert, right? No, put. And for example, I will have speed.id speed set. And so then here I can do set equals to field. The string will be the string will be try self sets map get component ID from self. Okay. Yeah, and this way it should technically work. But I don't really like this solution, so off camera I will try to optimize this thing, because not that it's slow, because it's mostly compile time, but it's ugly. Okay. So now I can finally insert entities. So this will return a usize, which will be the entity ID. And here I will get self And yeah, nothing else, I guess. Okay, so if let's say that this will be a constant ID, free IDs, or else entities. Okay. I will return this thing. Then entities self.entities will be incremented. Okay. And what else? Well, really nothing else actually, because if I don't add components, this is just a number and I don't even need to store it anywhere. And then I will do also remove. So self pool. Okay. Well, this gets actually a bit more complicated because I have to remove all the components from here. And I can just call this, but I need to know which components have this entity. And the only way to know this is basically to like iterate over every component. Yeah. Okay. I want to know if public function has component, and I will return a boolean. Sparse set. Okay. So if an entity has a specific component, it means that, so return self dot dense items at index self dot sparse dot items ID will be equal to ID. So in this case, the entity will have the component, and so also of course I need to know which entity to remove. Okay. And so now I just check. So self if self.speed set has component ID, I will have to self speed set dot move ID. Okay, and after all of this, I will have to decrement entities and free IDs push ID, which is not push but append. This is self and self. Okay, Well, really, this should almost be it for an entity component system. Let me add another component just to... So I want to also have position component with, well, let's say ID 0 and 1, and this will have X, Y, and Z. Okay. Yeah, so now I can just like create entities, add components, and remove entities. Let's see. Well, first of all, does it compile? Okay. Where is it? 26. Expected. What? Oh, so they should be constant? No? So what's the problem? I mean, aren't these the same thing? What? I mean, that's literally the string type. What's going on? Are you telling me I don't know how to use strings? Really? Okay. So string literals are... Yeah, this is the type. Error union is ignored. And also sets map. Okay. This and this. Okay. It didn't complain, so now I want to create a new entity. Entity pool insert std debug print new entity. And let's see. Oh. Oh yeah. Okay. And now I want to add the component I want to pull add component. What are the parameters again? So the type, the entity, and the component. Okay. So the type is speed. The ID is entity, and the value will be 5.0. Because this is not a field. Okay. Can't I do something like directly component.id? Because it's not a field. How do I access this thing? Should I make it public? No. Yeah, this is what I'm trying to do. So why it's not working? Also, I don't need this because I can just create a string hash map which contains no, okay. I need this. Or do I? No, I don't. I can just use a string hash map with a string hash map. Okay. And then here I will just put because I know there is something like type name. Yeah, okay. Type name. So I don't need what? Oh, it's type name. I don't need this anymore. Okay. And I can access this not by component ID but by type name of D. Okay, you can't get the comp time value. Okay, it makes sense. Otherwise I will lose all the checks. But why can't you? Like, so sets map get. Oh, can I? Yeah, I should for sure like make use of comp time, but this is hard. Well, I think I will figure this out off camera because it's already been 2 hours and I don't want to make live streams longer than 2 hours. So yeah, I will follow the schedule. So please join the Discord server so that you will know when I will be streaming next. So again, guys, remember to join the Discord server. That mostly became okay. And yeah, so see you, if I remember correctly, on Tuesday. Good night, guys.